Alright, so we're going to add the last couple of pieces for graphing the parabola. So we talked about the vertex and how does it face, and now the x and y-intercept. So at the end of the last video, I started talking about the y-intercept. So the y-intercept is just the point 0c. So that's as easy as finding whether it faces up or down, right? All I do is just look at c, and that's my y-intercept. The x-intercept, again, just like for lines, when we find the x-intercept, we have to let y equal to 0. So when you cross the x-axis, y is 0. When you cross the y-axis, x is 0. So when I set y equal to 0, I'm going to wind up with a quadratic in standard form. So I'm either going to have to factor or use a quadratic formula. But let's do the y-intercept first because it's easier. So because c is 4, the y-intercept is 0, 4. Now the x-intercept. We have 0 equals x squared plus 4x plus 4. So this is factorable, and it's a double root, x plus 2 times x plus 2. So the x-intercept, there's only one, and it's x equals negative 2. So the y-intercept is at 0, 4. The x-intercept is at negative 2, 0. For number 2, the c term is 0. So 0, 0 is the y-intercept. And now I'm going to solve to find the x-intercept. So I let y equal to 0. And this again is factorable. I can first pull out a greatest common factor, and then I set each of those factors equal to 0. So the first part's done. The 3x minus 5, I add 5 to both sides and then divide by 3, and I get 5/3. So the y-intercept was 0, 0. Well, the x-intercept, that 0, 0 is already accounted for. So that's part of it. And then the other is 5/3, 0. Number 3, the y-intercept is 0, negative 16. And then to find the x-intercepts, let y equal 0. Again, this is factorable. It's a difference of 2 squares. And my solutions are 4 and negative 4. So 4, 0 and negative 4, 0 are my x-intercepts. Number 4, c is 5, so 0, 5 is my y-intercept. Then to find the x-intercepts, I set y equal to 0. Again, I'm factorable. Oh no, I'm not factorable. I was thinking it was x squared plus 5x plus 4. That would have been factorable, but this is not. So let me put my a is 1, b is 4, and c is 5. So x equals the opposite of b. I'm using the quadratic formula, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that would give me negative 4 plus or minus the square root of 16 when you square that minus 20. So 16 minus 20 is a negative 4 over 2. So here I have a